All right, I'm back. We're on page 7 of note 6 of Calc AB. We're doing implicit differentiation, which has led us into the derivatives of inverse trig functions. And on the last page, we found the derivative of arcsine is 1 over the square root of 1 minus x squared, of arctan is 1 over 1 plus x squared, and then arccosine is just negative of the derivative of arcsine, so negative 1 over the square root of 1 minus x squared. Arccotan is the negative of the derivative of arctangent, so negative 1 over 1 plus x squared. You got to memorize those. Get on it. The sooner the better, because honestly, you're just going to use them all the time. So let's see about arc secant, which is the weirdest one. So let's do this. So the secant of y is going to be equal to x. Okay, so here comes our problem. So actually, let me do like a real triangle here. Okay, so we got our actual triangle, and then secant is equal to x. So secant is 1 over cosine. So cosine is 1 over x, which means that this is 1 and this is x, and that is a problem because that's the hypotenuse. The hypotenuse of a triangle cannot be negative. So what I'm going to end up doing, and I'm going to do it right now because it's the safest thing to do, I'm just going to put absolute value here. Like, what if x ended up negative? Like, what would we do? Well, one way around that is to put absolute value. I don't like how those are not like vertically aligned. I'm having trouble trying to do it like on the slanted hypotenuse there. It's weirding me out. Okay, so what's the missing side? So the missing side is the square root of the absolute value of x squared is just x squared. So x squared minus 1. All right, that's our triangle. So it's weird. And some people don't like it, and that's fine. You don't have to like it. But that's weird. Also, we're probably going to have trouble answering some of the questions because I probably just jumped the gun on that, but it's fine. All right, derivative. So the derivative of secant of something is secant of that thing, tangent of that thing, times the derivative of that thing, which in this case is dy dx. So the chain rule, right? So derivative of secant is secant tan, and then times the derivative of y, which is dy dx. And then this will equal 1. So then dy dx. So should we simplify this at all? Well, it's 1 over secant times tan. 1 over secant is cosine, so I'm actually going to write this as cosine of y over tan of y. I don't think I care about tan of y. Not that I don't care about it. I don't think moving it up as cotan is like a good idea. I don't think using sine over cosine is necessarily a good idea. I think we will leave it like that. All right, so I actually need to know 2 things. I need to know the cosine of y, which I actually sort of know because secant was like given. But in the triangle now, the cosine of y is 1 over the absolute value of x. And that's okay. And tangent of y is going to be opposite over adjacent, so square root of x squared minus 1. So we're going to take both of these. So this one is going to go with this one, and then this one is going to go with this one. All right, so we're going to make our substitutions, and we're going to see what we end up with. So use your triangle. So we're going to end up with dy dx is, so I have 1 over the absolute value of x, and then tangent is just the square root of x squared minus 1. So that's it. That's the derivative of arc secant. It's weird. So that's d dx of secant inverse is equal to 1 over the absolute value of x. Now, the interesting thing about this, or the really nice thing for us, is that this will not show up on the AP exam because not everyone agrees that this is the derivative. So I choose to interpret it this way. A lot of people do, but not everyone does. Some people do a really weird thing with the range of arc secant. And if you do something weird with the range of arc secant, you can totally avoid ever using the absolute value. No one really agrees on that fact. I will say, though, so there's nothing to modify. So we're good. So we're good. I should really rewrite the notes so that like I don't have to deal with this every year. We're good because we considered the absolute value already. If you look, I'm going to switch to the calculator for a second just to like show you. So here, that was our implicit problem from before. I'm going to graph arc secant. So I'll use the trig button. Arc secant of x. Look at this function. So this is an increasing function, right? So as you move from left to right, it is constantly increasing. I mean, it has like a serious problem, right, in its domain, but within its domain, you're always increasing, which means its derivative must always be positive. So that goes a long way to justifying our absolute value, as well as the fact that the triangle's hypotenuse can't be negative. So how do we fix that? You just put in an absolute value and then it'll never be negative. That's one of the ways of fixing that problem. So I think that we got it. Now the derivative of arc cosecant, if you needed it, would just be -1 over absolute value of x, radical x squared minus 1. I don't think anyone's ever going to ask you that. I mean, maybe they will. So you absolutely, no questions asked. I mean, ask every question that you have, but you definitely need to know arcsine and arctan, right? Those all the time, all day, make sure you know those. Arc secant, you don't need to know it. It might show up on the calculator section, but who cares? Because the calculator does all the work then. But in general, arcsine, arctangent, most important. Arc cosine, arc cotangent, just negatives of those derivatives. So like if you memorized some of them, you memorized all of them. But the calculator will take care of most of it. So make sure you know the ones you need to know. And I'm just rambling at this point, so I'm going to stop the video and I will come back in the next video and do a little bit more. So I will see you there.